Hello and welcome. Today we're going to be looking at the center, spread, and shape of distributions. This is another topic on the topic of problem solving and data analysis as part of the SAT math portion. As always, we're going to be looking at 5 questions. We're going to explain them and look at the intricacies in this topic so you can ace the SAT math portion. If you like these videos and found them informative, please be sure to like and subscribe. And with that, let's get started on our first question. We are given a table with the points on one side and the number of students on the other side, and we are told that Dr. Hicks gave every student in her class a 5-point pop quiz. The results are shown in the frequency table above. If the class average on the pop quiz was 3.25 points, how many students are in Dr. Hicks's class? All right, let's see what we can do here. So the average is going to be the sum of the points over the number of students. Sum of the points is going to be, let's see, we have 0 here, we have 1, 2 times 3, 6. Here we have 3x, and then 32, and then 15. So we can add that up, and we get, that's going to be 47 plus 7 is going to be 54 plus 3x over the number of students. Number of students is what? Well, 1 plus 1 plus 3, that's going to be the 5, plus the 8, 13, plus the 3 is going to be 16. It's going to be over 16 plus x. All right, well, now what do we do? Well, this is going to be equal to, we're told that this average is going to be equal to 3.25, right? So what we can do is we can multiply by 16 plus x on both sides, and we get that, 52 plus 3.25x equals 54 plus 3x. We can subtract 52 from both sides, subtract 3x from both sides, and we get that 1/4 x, or 0.25x, equals 2. So x equals 8. We're asked for the total number of students in Dr. Hicks's class, which is 16 plus x, and that is 24. So our answer is 24 students. 24 students in Dr. Hicks's class. Let's move on to the next question. All right, question number 2, here it is. And it says, the table at the left partially summarizes the percent of residents in different counties who participate in performing arts at least once a month. The percentages have a range of 12.9%. What could be the percentage of County G residents who participate in performing arts at least once a month? Let's see, how are we going to go about doing this? So the percentages have a range of 12.9%. So the distance between the highest and lowest are 12.9%. So the highest here is 17.3%, right? And the lowest is, what is the lowest? The lowest is 4.7%. So if we add the 12.9% to the 4.7%, we get that the max could be 17.6%. That could be the max. And if we take the 17.3 and subtract 12.9%, we get that the min could be 4.4%. So it has to be one of these two. Now, which one of these could it be? Let's add up the rest of these numbers right here and see what we can get. So we get 9.8 plus 8.8 plus 7.8 plus 5.2 plus 17.3 plus 4.7 plus 4.7. And that's going to be 58.3. So that doesn't really tell us anything. Right, so that's right, number. Let's go back to our 4.4% and our 17.6%, and let's think about what we can do here. Well, we have that the minimum could be 4.4% and the maximum could be 17.6%. We don't know anything else about this. Right, so the percentage of County G residents participate in performing arts at least once a month could be either of these two values, because either of these two values have a range of 12.9% for the entire data set. So our answer is that it could be either of them. So we can go with, say, 4.4% right here, but we can see right here that we can, if we scroll down to the solution, you can see that either 4.4% or 17.6% of residents participate in the performing arts at least once per month. Either of these would be acceptable answers, does not really matter. But let's move on to our next question. All right, we're given another table, and this is what we're told. The time in minutes rounded to the nearest minute that runners took to finish a 3-mile race is shown in the table to the left. If the mean finish time is 21 minutes, what is the value of R in this table? So we're going to add up the total number of minutes, which is going to be 18. It's going to be 18 plus 19 times 2, so 38, plus the 20 times 3 is 60, plus 21 times 6, 126, plus the 22R, plus the 23, plus the 24 times 2, which is 48. So essentially, we have that 313 plus 22R over the total number of runners, which is 1 plus 2 plus 3 plus 6 plus R plus 1 plus 2, or 15 plus R, is going to be 21. 21. All right. Now we can multiply by 21 on both sides, and we get that 315 plus 21R is going to equal this part. We subtract the 313 on both sides, we subtract the R on both sides, and we get R equals 2. The value of R on the table is simply just 2, and we can move on to the next question. All right, we've given yet another table. Let's see what we can do with this one. The table to the left partially records the number of pairs of socks manufactured by a company each quarter. If the median of all 9 quarters is 11,830, and the range is the same with and without quarter I, which of the following could be the number of pairs of socks manufactured in quarter I? Well, we're told that the range is the same with and without quarter I, so quarter I has to be in between the max and min, which is 10,765 and 15,072. So it has to be in between those two. So we can immediately cross out a couple of them. We can immediately cross out answer choice A because it's too low. We can cross out answer choice A, it's too low. Cross out answer choice D, it's too high. And then we have to deal with the rest of them. All right, so now what are we going to do? Well, we can just say we can find the median of all 9 quarters, or the median of all 9 quarters is going to be 11,830. So we can cross them out from each side. So we can cross out the lowest, we cross out the highest. All right, now if B is the correct answer, then this would be the next lowest. But let's assume for a second that it's not B, right? Just so that we can keep crossing these out. Right? And we see that 11,830 right here is supposed to be the median. Right? So that means that it has to be out of these 5 plus this extra one over here in I. There has to be 3 on each side of it. So we can go from the top and we can cross out 1, 2, and 3 above it. Meanwhile, we can only cross out 1 and 2 below it. Right? And that third one that has to be below it is going to be over here. It's going to be this one right here. So it has to be below this 11,830. So our answer has to be less than that. So it is then going to be choice B, 10,816. And we can move on to the next question. All right, let's see what we have here. We have the birth weight of piglets in kilograms with 14 different values. And we're told that this table above lists the weights in kilograms of the litter of newborn piglets, of the mean, range, and standard deviation of the values listed, which will decrease if the 0.98 kilogram measurement is removed from the data. Well, 0.98 is an outlier, right? It's far less than everything else, which means that if we take that away, the mean has no longer an outlier on the bottom, so the mean is going to go up. So mean goes up. Now the range, well, we cut the range down because we took away one of the ending values. The range goes down. And now for the standard deviation, well, we took away one of the outliers, which has the most standard deviation. So by taking that away, the standard deviation goes down. So the standard deviation goes down, the range goes down, and the mean goes up. We're asked which will decrease, so it's going to be range and standard deviation only, or answer choice C, and we're done. All right, so on this topic, you can see it's mainly just about utilizing those functions we already know, the mean, the range, the median. We have mode, even though we didn't see it. We have standard deviation. Being able to think about those values and being able to use those values in these kinds of questions. That's really all the topic is. That's it for this topic, and I'll see you next time.